This video here looking at percent composition. So what is it? Percent composition is the percent by mass of each element in a compound. To calculate this, you're going to take the mass of each element divided by the mass of the compound times 100. So for compounds, you're going to do this a couple of times, one for each element, if that's what the question asks for. So a couple ways I can present you problems. The first is I give you grams. So this one, a compound is formed when 9 grams of magnesium and 3.5 grams of nitrogen combined. What is the percent composition? Well, if we look back there at our formula, we need the mass of the compound. So to do that, we need to figure out what that mass is. So 9.03 plus 3.48 gives me 12.51 grams. And that's of the compound. Then for magnesium percent is going to be 9.03 divided by 12.51 times 100. And then for the other one's nitrogen, this is going to be 3.48 divided by 12.51 times 100. Plug this in your calculator. Do the bottom one first. 3.48 times 12.51. Oops, or divided by 12.51. Times 100 gets me 27 point, and looking at sig figs here, going to keep 3, so one more, 0.81%. I can do the top one, or I know percents always have to add up to 100. I could do a subtraction. I'm going to type it in my calculator just to see. Divided by 12.51 times 100, and I do get 72.2 if I round. Notice they do add up to 100 or something really close to it. That's always a good check as you're doing these problems. The next question then, if you are given a formula, so if you're given a formula, first thing you need to do is you want to assume you have 1 mole of the stuff, because what that lets me know is if I assume 1 mole, well, I know how much this weighs then, so I know the mass of one compound, and I just have to calculate its molar mass. So barium is 137.33 plus carbon 12.01 plus oxygen 16, but I have 3 of them. So the mass of this stuff, if I do the math, so barium plus carbon plus 3 oxygens gets me 197, and I can go read that, 0.34 grams per mole. But I assume I have 1 mole, so I'm left with just grams. This is a case where it kind of helps to maybe show your work a little bit. That way you don't have to keep going back and forth to your periodic table. I didn't, so I have to go back and look. So to figure out percent barium, I need to, well, the whole thing weighs this much. Barium, of that molar mass, barium was 137.33 grams, divided by that total, 197.34 times 100. So really, you're doing the exact same calculations. This one you just had to do a little background info, a little kind of side work to do these problems. We're going to do the same thing for carbon. Carbon is equal to 4.0 12.01 divided by 197.34 times 100. And then I got one more, and that's oxygen. Oxygen is equal to, it was 16 times 3, so 48.00 divided by 197.34 times 100. And then again, just plug it into your calculator. Make sure everything adds up to 100 when you are done, and you got it. Divided by 197.34. So this first one, and it looks like I actually get 5 sig figs for this one. 69.591%. Bottom one, 12.01 divided by 197.34 times 100. Gets me 4 sig figs, 6.086, and that's rounded percent. And this last one, hopefully it's something around 24, 48 divided by 197.34. Oops, I type it in right. Times 100 gets me 24.32% oxygen. Make sure that you do kind of label your answers a little better, at least kind of keep it in line with, this, or, maybe write your final answer as like percent barium equals 69.591%, percent carbon equals 6.086%, and then percent oxygen equals 24.32%. Maybe make a little table like that too, especially if your work's kind of all over the place like mine. The last one then, so how many grams of barium can be obtained if I have this much barium carbonate? Well, if we look, this is an application of our last little work here. We know what the percent barium is in this compound. So I know that this compound is made of 69.591% barium. Get rid of the rest of this. So if I have 135 grams of it, 69% is going to be barium, 6% of that mass is going to be carbon, and the final 24% is going to be oxygen. So this question here, if you already have percent composition of this compound, we're just going to go ahead and use it. And for some reason, this is the easiest problem, and this is the one that people always mess up. So to do that, we know that of our 135 grams, we know that 69.591% is barium. All we have to do is multiply. We are multiplying by a percentage here, so make sure you move your decimal 2 places to the right. That gets rid of the percent, and now it's just plugging it into your calculator. 135 times 0.69591. So of that 135 grams, 93 and I get 3 sig figs here, 93.9 grams of it is barium. So that's an application of the percent composition. So it is the percent by mass of the compound. So if you know how much of the compound you have, and you know the percent comp, you can figure out how much barium you can get from that. Useful if you're trying to figure out how much of this ore you need to get so much metal or something like that. But that is the last. That is the last type of problem you're going to see for percent composition right now.